Or do we cover this already?
No, it's sort of.
Alright, so we talked about acids being strong or weak, and now we'll round it off with talking about a base. What is the difference between an acid and a base? And a base is something that accepts a hydrogen ion. So if there is a hydrogen ion in solution and it'll combine with something with a negative ion, that makes it a base. Another word that we use is alkaline or alkaline to describe something that has a high pH or a base. Does it say on here that a base would have a high pH? No, it doesn't. So you need to add that to your notes. A base is a pH higher than normal, and in the blood, normal is 7.40.
Higher than what?
7.4, the exact number is 7.45. Anything greater than 7.45 is considered alkaline in the blood. And this one you don't have in your notes, it's just a question. Which of the following is considered a base? Would a bicarbonate ion that has a negative charge be considered a base? Can it combine with a hydrogen ion? All right, so in your notes, if you just want to write HCO3 minus, and then write the word base with a question mark, and then put yes, so you know when you're going back through your notes what we discussed. So HCO3 minus can accept a hydrogen ion, so that makes it a base. Water, think water accepts a hydrogen ion? No, so put base next to it with a question mark and then put no. Water is not a base. It's a neutral substance. And hydrogen chloride, do you think that's a base? Can it accept a hydrogen ion? No. So base, question mark, no. It's actually an acid, a strong acid, hydrogen chloride. So acids can be strong or acids can be weak. And we care because it's going to eventually lead back to breathing and how the body regulates the pH of the blood. So that's why we're going through all this acid-base stuff. So a strong acid ionizes almost completely in an aqueous solution. So it shows strong acid and it has hydrogen chloride with this big thick white arrow, meaning that it mostly all ends up as hydrogen ions and chloride ions in a solution. Almost none of it stays together. So if almost none of it stays together, it's a strong acid. A lot of hydrogen ions are released in solution. Is there a drama class next to us? Carbonic acid is considered a weak acid. If I didn't tell you that this is carbonic acid, would you remember? Yeah. All right, if not, then just write, squeeze the words in here somewhere so you remember. Carbonic acid is considered a weak acid. And then notice the white arrow is thickest, leaning towards the combined molecule of H2CO3. So very little of it is separates into hydrogen ions and bicarbonate ions. Most of it stays together. Since most of it stays together, that's considered a weak acid. It says that the three are in equilibrium with each other. However, there is more carbonic acid. So if I were to ask you the difference between a strong acid and a weak acid, would you be able to know the difference? Could you give me an example if I asked you? So is hydrochloric acid a strong acid or a weak acid? Strong. Why is it strong? It comes apart. Mostly all of it comes apart. What about carbonic acid? Is that a strong acid or a weak acid?
Weak acid.
And why is it a weak acid?
Because
Most of it stays together. Okay. All right, so this leads into talking about a buffer solution. A buffer solution resists changes in pH when an acid or a base is added to it. And in the blood, we have the bicarbonate buffer system. That's sodium bicarbonate. Sodium bicarbonate, carbonic acid are the same, but there's one difference. Do you see it? See the difference between this and carbonic acid? Yeah, one of the hydrogens is replaced by a sodium. So sodium bicarbonate. So what's nice about having sodium bicarbonate in the blood is it can take strong acids and convert them into weak acids. So here it shows hydrochloric acid being added to the blood. No, that doesn't happen. So this is just theory. So you add hydrochloric acid to the blood, but sodium bicarbonate will combine with the hydrogen ions and form the weak carbonic acid and sodium chloride, which is salt. So that's an exaggeration, but it's how the body keeps the pH balanced. So it tells you if a strong acid, such as hydrochloric acid, is added to the solution, the strong acid is converted to a weak acid. This prevents a large change in the pH of the blood. Last week I gave you some examples of acids being formed in the blood. I know hydrochloric acid isn't one, but do you remember any of the other ones that I mentioned? What if you are not getting much oxygen delivered to the tissues? And your cells still need to produce energy, so what can they do if they're not getting oxygen?
Anaerobic metabolism?
Yes, anaerobic metabolism has a byproduct. And what was the byproduct? Lactic acid. So oxygen not delivered to the tissues in adequate amounts, lactic acid builds up. Lactic acid spills over into the blood, and now you've got a low pH in the blood. The body can't function with a pH that's outside of the normal range. So it's going to try and do what it needs to do to get that pH back in range. So the lactic acid, those hydrogen ions on the acid, is going to combine with sodium bicarbonate. All right, so I mentioned lactic acid, and I think there was two more that I told you about. Do you want to look it up? Ketones? Yes, ketones. So if glucose can't enter the cells, then the cells start producing ketones, keto acids, and then those acids spill into the blood. So if we have a lot of ketoacidosis, how can the body neutralize those acids? We've got somebody diabetic, ketoacidosis, and those ketones spill over into the blood. Is there anything in the blood that could balance that strong acid and make it a weaker acid?
Sodium bicarbonate.
Sodium bicarbonate, yes. So that's the purpose of sodium bicarbonate in the blood. It takes a strong acid and makes it weak. So to write a summary on your notes, carbonic acid, and you can write down H2CO3, or you can write down carbonic acid, is very important in maintaining a normal pH, in the blood. So that's the summary of all this acid-base stuff, is that we've got that bicarbonate buffer system in the blood. And this is just explaining, the same thing happens with a strong base, how sodium bicarbonate can combine with a strong base and fix that problem too. Sodium hydroxide is a strong base. It combines with carbonic acid and forms sodium bicarbonate in water. So just another example, it took a strong base and made it a weak base. So getting into the buffer system of the body, there's a formula that I use. And this explains a little bit about how the formula comes about. Talks about pK. The pKa is the pH at which an acid is 50% dissociated. pKa is the most effective pH point for buffering. The pKa for carbonic acid is 6.1. This is not something where I'm going to say, in a short essay, explain pKa. We're just going somewhere with this. So talking about the pH of a buffer system, the amount of bicarbonate is in equilibrium with the amount of carbon dioxide. And that's where our formula is going to be. It says this is represented by the Henderson-Hasselbalch equation. It calculates the pH of the blood's buffer system. So as long as the ratio of bicarbonate to carbon dioxide is 20-to-1 ratio, the pH will be normal. So here's this famous equation, and it has 6.1 in it. So if you were ever to ask me, well, what is 6.1 and where did that come from? I'd go back to the slide that sounds like Greek, and I would say from here. So this is when we have 50% dissociation of the hydrogen ions for the bicarbonate buffer system. Not important, well, I guess it's important, but as far as clinical, are you quizzed, when you go around with the physicians, do they say, okay, the Henderson-Hasselbalch equation has 6.1 in there, what is the 6.1 for? You'll never get asked that question. So, the equation, Henderson, say that fast anytime, Henderson-Hasselbalch is an important equation, and this is something that stays with you. Well, the beauty of this is you can predict what the pH of the blood is going to be by looking at the bicarbonate ratio to CO2. It involves the logs, so I don't have you plugging in numbers. If anything, you can download an app on your phone, like Scientific Formulas, and Henderson-Hasselbalch is in there. Sometimes you're given a blood gas, and the numbers just don't add up. And you'll see the pH, and you'll see the PCO2. So if you have that app on your phone, and you plug in the pH and the PCO2, it'll tell you what the bicarbonate is supposed to be. Or if you're wondering, well, what should the pH be, then you plug in two of the numbers. So if you know two of the three, you plug it into the equation on your calculator. Again, you're not going to be hand calculating this. And it'll tell you your missing value. If you have more bicarbonate than you do CO2, you're going to have a higher pH. So this number would be greater than 7.40. Or if you have more carbon dioxide than you do bicarbonate, that will lower the pH. Clinically, a blood gas analyzer measures the pH of the blood, the carbon dioxide in the blood, and then it calculates the bicarbonate in the blood. So bicarbonate is not a directly measured value. It's just estimated from that equation. Does that make sense, or do you want to rewrite it? So when you put the blood in the machine and you get a printout of values and it prints out the bicarbonate, it's not directly measuring bicarbonate. It's just plugging the pH and the CO2 into the Henderson-Hasselbalch equation and telling you what the bicarbonate is on the blood gas printout. Does that already make sense on that bullet, or do you want to rewrite it?
No, it makes sense.
It makes sense? Okay. We can use the Henderson-Hasselbalch equation to find an unknown if we already know 2 of the 3 values. Okay. Well, do we have any practice? What do we have to practice here? Well, let me finish the handout, and then I'll give you guys a few minutes, and I'll look at it. I think it's in D2L, where it has the Henderson-Hasselbalch equation. We can plug some numbers in and see what happens. All right, so how do we get rid of acids from the body? It tells you the lungs and the kidneys work to get rid of acids. So those are the primary acid-excreting organs. Lungs will excrete volatile acid. Remember, volatile meant that it turns into a gas. It turns into CO2. It says lungs excrete volatile acid, the CO2 from dissociating carbonic acid. Kidneys excrete fixed acid into the urine. So those acids actually make their way through the kidneys and into the filtrate and into the urine. Kidneys, forming urine, inside the kidney, you have your glomerular filtrate. This doesn't show a lot of detail. I think we needed a picture of the glomerular filtrate being formed. That's not a big help right there. Oh, here it is. So when blood perfuses the kidneys, blood comes to the kidney and it goes through these little tiny units. And that's the glomerulus. And the filtrate is forced through. And this filtrate that forms, some of it becomes urine, some of it gets reabsorbed by the blood. So that's all occurring in the glomerulus and in the tubules after that. So acid will be filtered out, and it will become part of the urine. How the kidneys work. Blood going to the kidneys is filtered through the glomerulus. The filtrate that forms contains many substances from the blood. If the body needs to keep some of these substances, they will be reabsorbed back into the bloodstream. If carbon dioxide is high in the blood, then bicarbonate is reabsorbed. Do you know why? If you have a lot of CO2 in the blood, why would it keep the bicarbonate?
To buffer.
Yeah, it wants to buffer that high CO2, which is like an acid when you have extra CO2. It wants to keep that ratio 20:1 so that you have normal pH. If the carbon dioxide is low, if somebody's hyperventilating all the time, then bicarbonate is excreted in the urine. Again, low CO2, you need low bicarbonate to keep the pH in range. These mechanisms maintain the body's pH within normal limits. And this is called acid-base homeostasis. The process is slow in the kidneys. It takes several hours to several days for it to balance out the pH. The lungs can respond quickly. The kidneys, not so quickly. It takes them a while to adjust the pH. That ends it. All right, let me see if I can find the
Wait until for that test. That's a lot of
Okay, I did find it. It's in D2L, but it's under links. So it's, did you see how I got to it?
Could you go back?
Up at the top, you've got email, links. So if you click on links, you'll get to it. And this is all in links. All right, I want to enter bicarbonate level and carbon dioxide and get the pH value. Or it says if I want to, I can put in the pH and the CO2 and get them. Let's start off with this one. Make up a pH for me. You can give me a normal, you can give me an acid.
7.2.
7.2. And what is the carbon dioxide level? You can give me normal, high, low.
37.
37?
Yeah, there you go.
And calculate.
14.
And the answer is 14. So bicarbonate would have to be a level of 14 if that's the pH and that's the CO2. And let's switch back.
It's a switch.
Oh, thank you. Okay.
Very good.
I didn't tell you what a normal bicarbonate level is for the blood. It's 22 to 26 milliequivalents per liter.
What? That's not bad.
Sometimes I need that jolt. So 22 to 26. And then for milliequivalents, instead of writing out the word milliequivalents, do little m, little e, little q. Milliequivalents, M-E-Q. And then put a slash, and then put a capital L for liter, milliequivalents per liter. So those are the units for bicarbonate. Yes.
Would it be a correct assumption to say that this really won't be on the test since we won't have this little type of calculator type thing? Or is it something about this we need to remember?
Yes, there is stuff that you have to remember. In order to have a normal pH, you have to know the ratio needs to be 20 to 1. For CO2 to bicarbonate. And you have to know the name of the equation. You have to know if you put in two values, it can give you the third value. You have to know that this is the equation that a blood gas machine uses to figure out what the bicarbonate level is in the blood. And you have to recognize the equation. You don't have to plug into it, but you do have to recognize it. All right, so I just gave you a normal value for bicarbonate. Do you want to plug in the normal value, or do you want to play with a higher than normal value, or lower than normal value? 30? And what is the level of the CO2? 47. So if the bicarbonate level is 30 and the CO2 level is 47, you get a pH of 7.42. Do you know if that's normal range or not?
It's right.
Is it a five,
Yeah.
7.45, right?
Yes. How can we get like a high pH in here? What can we do to get a high pH? CO2 is like an acid, so let's put in a lower number. Give me a lower number.
25.
25? Yes. Whoa, check out that pH. That's going to cause a lot of cardiac arrhythmias. That's a dangerous pH. Yeah. All right, so that's there for you guys to play with. All right, so I guess your brain cells are still ready for more, right? Keep going? Or you're not ready for a break yet? I wonder if we'll finish everything before we need a break. Urial blood gas interpretation is next.
Is the ABG on the exam part too?
The part that we're going to go through today is, yeah, so you have next week off and then an exam 2 weeks from now.
For that exam, it's just this packet? Or not that? Right, okay.
Part of this motion.
And some stuff from last time, right?
Always.
Count 'em all.
Thank you, Richard.
Somebody else is telling you the same.
Yeah, so I
Has
have
that.
I'll do it today, sorry. Yeah, I never got the response that said that.
Oh,
Yeah, so.
Yeah. My brain's overload.
Brain says no.
It's a lot of numbers in here. I could deal with them. You can see child alone. This is gonna happen in a break.
Yeah.
Not just because of this.
They have basic
I didn't stop the recording now, so I guess that rushes us to keep going. So we have a sponsor for our lecture, Edith Wright. Took care of a 65-year-old female post-op patient who has cancer of the colon. She has a 50-pack-year smoking history. Do you know how they arrive at pack-year smoking history? They asked the patient, and you're going to be doing this with your pulmonary function patients and when you're getting an assessment from your patient. One of the histories that you ask is, well, what is your smoking history? And if they say, oh, I smoke about a pack a day, and then you ask them, well, for how long have you been smoking a pack a day? And then they'll say, 20 years, 30 years, and then you multiply those two numbers. So if they're smoking 3 packs a day for 30 years, then 30 times 3 would be 90 pack-year smoking history. How can you possibly smoke 60 cigarettes in a day? Somehow people do that. Yes. Yeah. They have to be rich to afford that. That's what, $20 a day, 7 days a week?
Well, back then, was it Barton really cheap?
Yeah.
You know somebody who smoked 3 packs a day?
No. I'm just saying, like, because when I worked at Holy Cross and for cardiopulmonary rehab, and, you know, they would come in, we have to ask them that too, and they like, the carton was like, something like a ridiculous number, I'll just make up on like $3 or something for like a whole carton, and they would just do that, I'm like, crazy.
So as long as the price was affordable, they keep smoking? That's a tough one. So this lady was very weak post-op, she developed pneumonia, and that happens a lot. If there's retained secretions in the lungs, bacteria can start breeding in the retained secretions and pneumonia sets in. So secretions were very thick, she required high-flow oxygen therapy, and you'll learn about that probably next semester. She's getting nebulizer treatments every 4 hours along with chest physiotherapy. I've been in the hospital for 5 days now. I woke up last night during the night and I couldn't catch my breath. The nurse called my therapist and she was there right away. My lungs were full of mucus and I couldn't cough strong enough to clear them. The therapist gave me a nebulizer treatment and had to suction the mucus out of my lungs. It was miserable. I was so happy I could breathe again. Apparently, the mucus was so thick it blocked all her airways and she couldn't clear it. How do you guys feel about having to suction patients?
Very
I mean, it's
Think of the greater good.
think of the greater good?
Yeah,
Yes, that's true.
that's my approach.
On a patient like that, are you just using the anchor?
No, you'll have to thread a catheter through the nose and go into the trachea.
I'll go over now.
Yeah,
It just looks like it hurts.
and it does. It's really uncomfortable. I mean, to use lidocaine in the nose is the better way to go. But just to go, lubricating jelly and to thread it through, that's really uncomfortable. And then when you're poking at the epiglottis and it starts coughing, that's, yeah, it's not a fun thing to do to people. Oh, yeah, with trach patients, yeah, they propel their mucus and never stand at the bottom of the bed. I have seen it. Don't stand at the end of the bed. All right, so arterial blood gases, we need to draw blood from an artery. And the typical site is from the radial artery. So you become experts at how to palpate the radial artery, stick the radial artery, and then you get your blood sample. We're going to go through a packet in a couple weeks about the technique that you use when you're drawing the blood. Then once you put it in the machine and you get these values printed out, then you need to interpret the values. So the 5 values from an arterial blood gas is, so write this down in your notes. The 5 values from an arterial blood gas . 5 values from arterial blood gas. Number 1, pH. Number 2, PaCO2. Little a, yeah, from the artery, PaCO2.
The more, I apologize, the more was what?
pH.
pH, okay.
Number 3, PaO2. It's from the artery, so little a. Number 4, HCO3 minus, bicarbonate. And number 5, base excess. Base excess, EXCESS, base excess. All right, there's other values that print out, but these are the 5 that we're focusing on now. All right, so step 1, when you're interpreting the results, did you miss some of that, John?
It was PaCO2 and PaO2, right?
Yes. All right, so when you're analyzing a blood gas, the first thing that you always look at is the pH. You don't go anywhere else until you've looked at the pH and made a determination if the pH is in normal range. Normal is 7.35 to 7.45. And when you say the pH is, you don't put any units after the pH, you just say the pH is. If the pH is higher than 7.45, that's called alkalosis. You can say, oh, the pH is alkalotic, or the pH shows alkalosis. If the pH is less than 7.35, that is called acidosis. You can say the blood is acidotic. When the pH drops less than 7.20, then the body doesn't function well, because in order for the tissues of the body to function normally, the pH needs to be in range. So there's a little bit of leeway, but if it drops below 7.20, you begin getting cardiac arrhythmias. So instead of a normal sinus rhythm, you start getting irritability in the cardiac muscle, and you get a lot of arrhythmias. The ventricle does not contract as well with a low pH, so that's why it's important for us to want to recommend treatment if the pH drops too low. Analyze the respiratory involvement, the PaCO2. So that's your second step, is to look at the PaCO2. And probably because of routine, PCO2, PaCO2 are the same. So if you're talking about a blood gas and you say the PCO2 is, it means the same thing as the PaCO2. It's just that, you know how we, instead of saying do not, we say don't. So instead of saying PaCO2, sometimes you'll hear the PCO2, same thing. Is controlled by alveolar ventilation, so the air going in and out of the alveoli, and is the indicator of respiratory involvement. So a normal range for CO2 in arterial blood is 35 to 45 millimeters of mercury. High levels of carbon dioxide in the blood create acidosis. Low carbon dioxide levels in the blood create alkalosis. So if somebody has high CO2, we can say they're hypercapnic. They have hypercapnia. Well, that's just a term to use. Hypoventilation, I think we've mentioned hypoventilation in the past, is when the respiratory rate or the tidal volume is less than normal. So when you don't have enough air going in and out of the alveoli, CO2 starts to build up in the alveoli, it starts to build up in the blood. So it says this PaCO2 will increase. So if somebody's not breathing, the CO2 increases in the blood.
Hypoventilation goes with hypercapnia.
Yes. All right, step 3, then you're going to analyze the metabolic involvement, and that's when you're looking at the bicarbonate level. A normal range is between 22 and 26 milliequivalents per liter. The bicarbonate ion is like a base. So bicarbonate levels higher than 26 milliequivalents per liter in the blood create alkalosis. High bicarbonate, alkalosis. Bicarbonate levels lower than 22 milliequivalents per liter in the blood create acidosis. Got that? So if we have extra bicarbonate in the blood, do you think the pH would be higher than 7.45? Or would the pH be lower than like 7.35? We have a lot of bicarbonate. Would bicarbonate change the pH of the blood to be alkalotic, like a high pH, or would it change the blood to have a low pH? High. Very good. And I have a handout for you. Julie, can you stop the recording, please?
0.15, and you've got the serious cardiac business.
Yeah, but I'm just asking if it's alcoholic,
okay.
acidotic.
Oh, okay. Yes. Thank you.
All right, so we're going to apply those steps and analyze the blood gas. So there's two columns here. Here's a set of blood gases, and then on the right there's a set of blood gases. So first one, 7.34 is the pH. So if we look at a pH that's lower than normal, is that considered acidosis, alkalosis? That's acidosis. And then we look to see what's causing the pH to be acidotic. So let's look at the the carbon dioxide and the bicarbonate level. Carbon dioxide is 49. Is that alkalotic, acidotic, normal? Yeah, high CO2, that's like an acid in the blood, and that's acidotic. So you would write acidotic here. And what about bicarbonate level? Normal is between 22 and 26. So that's normal. So write normal underneath it. All right, so what is the cause for the pH to be acidotic? Is it the high CO2 or is it the bicarbonate causing the acidosis? Yeah, it's the high CO2. So we would say this is a respiratory acidosis. So somewhere you have to draw a line on your paper and write respiratory acidosis. And that's all we're doing right now. It's just looking at those three values and determining what's causing pH to be out of range if it is. And then when we finish, by the time we finish the handout, I'm going to be asking you, okay, well, what would cause respiratory acidosis? And so it goes from there, but this is just the beginning. On the right, we have another blood gas. The pH is 7.34. Is that in normal range? No, that's an acidotic pH. So now let's look at the carbon dioxide and the bicarbonate level to decide what's causing the pH to be acidotic. The CO2 is 40 millimeters of mercury. That's in normal range, so write normal underneath it. Now look at bicarbonate level. We know that normal is between 22 and 26. What if bicarbonate is lower than normal? Does it create acidosis or alkalosis? Yeah, it creates acidosis. So write acidotic underneath the 21 milliequivalents per liter. All right, so if I ask you what the cause of the acidotic pH is, what would you tell me? Yeah, it's a metabolic acidosis. So you need to label it. Label that blood gas as a metabolic acidosis. Okay, then we have some more blood gases. We have a pH of 7.48, CO2 is 40, PaO2 8, we're not looking at pH. Bicarbonate 29, with a +5 base excess. So is the pH normal, acidotic, or alkalotic? It's alkalotic. The higher it goes, the more alkalotic it is. Now we want to figure out what's causing the pH to be alkalotic. Is it the level of CO2 or the level of bicarbonate? Oh, okay. So under CO2, you write normal. And then under bicarbonate, you write alkalotic. And then you would label this blood gas as a metabolic alkalosis.
Metabolic.
alkalosis, alkalosis. All right, we have a 7.4 pH, a little distracting, isn't it? pH 7.48, CO2 is 30, bicarbonate is 24. So the pH is alkalotic, and we're looking for the cause of the alkalosis. Right, 30 is below the normal range of CO2. When you have lower than normal level of CO2, that's alkalosis. And bicarbonate is in range. So we have the low CO2 causing the pH to be alkalotic. So we would call this respiratory alkalosis. Julie, can you stop the recording?